Hi, welcome to the video solution for Edexcel IAL Physics. This is a very short video solution of one question from January 2016. It is the request of one of my subscriber. So let's start. Question number 19. A lorry gradually accelerates from rest. There is a box of mass 200 kg on the back of the lorry. This box is not tied to the lorry. The lorry accelerates from rest to speed 15 over a distance of 39 meter. Show that the acceleration of the lorry is about 3 meter per second square. Basically, this is a straightforward question. The lorry is accelerating from rest to the speed of 15 meter. That means initial speed is 0 and the final speed that the lorry is getting is 15. This is u, and sorry, this is v, and the distance covering by the lorry in this acceleration time is 39 meters. So this is the distance travel and we need to figure out the acceleration. So of course we are using to we will be using equation of motion, which is v square is equal to u square plus 2as, and we need to find acceleration. So rearrange this equation for acceleration. A is equal to v square minus u square upon 2s. Just substitute the value. A is equal to 15 square minus 0 square divided by 2 times of 39, and acceleration will be 2.9 meter second minus 2. This is the acceleration, which is about 3 meter per second square. Okay, next part, the maximum frictional force between the lorry and the box is 630 Newton. Explain why this limits the maximum acceleration that the lorry can have without the box falling off. Your answer should include a calculation. Now, what this question is saying, that the friction force acting is 30 Newton, and why this friction is sufficient for the box so that the box does not fall. That's the meaning exactly. So what do you need to do? First, you just try to see what is happening. The lorry is accelerating forward. That means the box will be experiencing a forward force, which is F, and this F is due to force of the engine of the lorry, and then the box has a backward friction force. So I will just say that this is engine force Fe and this is friction force F, which is about 630 Newton. And in this part we need to show that there is no net force on the box, meaning the forward force is equal to the backward force. If these forces are balanced, that means the box does not have any resultant force, so it cannot accelerate backward or maybe forward additionally. So let's calculate the forward force, and this, remember, this forward force is also acting on the box. The forward force F was be equal to ma. So Fe is equal to ma, and this m is the mass of the box, so which is 200 times acceleration, and the box has the same acceleration as acceleration of the lorry, so 2.9. So forward force or engine force on the box is 580 Newton, or you can round it off. F is equal to 600 Newton. So this is forward force, and if you see, the forward force Fe is approximately equal to the friction force, about equal 630 Newton. So there is no net force. There is no net force that can cause the box accelerate individually or independently, so the box will not fall. Part B, once the lorry has reached its destination, the back of the lorry is tilted at an angle theta to the horizontal. The three forces acts on the box, the W, the normal contact force and the frictional force. Okay, so this is the case of basically inclined plane. Inclined plane. A plane that makes some angle with the horizontal. So this is the free body diagram. This is inclined plane, IP, if you wish. State expression for the component of the weight of the box parallel to the back of the lorry and the perpendicular to the back of the lorry. So if you recall, if you have studied inclined plane as a separate topic, you know that for an inclined plane, the key idea is you need to understand the component of the weight. So this is the particle, and this particle is experiencing three forces. One is R, and friction force, of course, well, no matter what, the box is going to slide down if theta keeps increasing. That means the friction should be acting in uh, upward direction. So don't confuse with this case with the previous one. In the previous one, the base of the lorry was horizontal, so friction was acting, you know, uh, leftward, but here the friction will act along the inclined plane upward direction. So this is friction, this is R, and weight is acting here. So the idea is, this is the weight, you need to resolve W into its component. And if you are okay with the resolving vector, the easiest way is the vector which is need to be resolved, you think or you look at the head and the tail and try to draw a right angle triangle. A right angled triangle. A right angle triangle in which both the components should make 90-degree angle. So if you see, you need two components. One is should be parallel and one is perpendicular to the back of the lorry. And this line, this inclined plane is basically showing back of the lorry, this one. So both the component should be drawn in a way that one component should be parallel and the other component should be perpendicular. So you see, this is the tail and this is the head. So you draw a line which is perpendicular to the inclined plane or perpendicular to the back of the lorry. So one component is this and the other component would be parallel. So draw a parallel line. Now you see you have a right angle triangle. And what about the arrows? So arrow of these component, this is another important concept. Most of these students get confused how to draw the arrows on the component. So think yourself is standing at the tail of the vector, in this case tail of the weight. Here this is the weight tail, and start walking along the component. So when you walk along the component, so this is the first arrow, and keep walking along the component. When you are about to reach to the head, this is the second. Now you see you have these two components of the weight. Clearly this component is perpendicular to the plane or perpendicular to the back of the lorry, so you can call it component W perpendicular, and this component is acting parallel, so you can give symbol W parallel. These are just symbol, you can say W1 W2, but it's your choice. And now what should be the values of these components? Remember, this angle is theta, which is inclined plane is making. That means this angle is theta. So if you use your geometry, I don't have this much time, in some other video I will explain that if this angle is theta, then we can easily show that this angle inside this right angle triangle, this angle must be same as this. If this angle is 30, it will be 30. Now clearly this is the opposite component, opposite, and this one is adjacent component. adjacent, meaning the opposite component should use sine, and the adjacent component we use cos. So the W perpendicular component will be W cos theta, and the parallel component will be W sine theta. So the summary is this weight has two components. One is parallel to the back, so you can draw something like this, and this is W cos theta, which is a perpendicular component, and the other component is parallel component, parallel to the plane, acting on the box. So you can draw this component here. This is W sine theta. So this is parallel component that you need to write. So parallel component and perpendicular component. The angle theta is increased until the box is just about to slide. It is really important. The angle theta is increased until the box is just about to slide. This word is important, about. About means the box is not sliding. It is just about. Still the box is at rest. So at that moment, the friction force is given as F is equal to 0.32 R and calculate angle theta. Now, if you go back and see the diagram, in this diagram, we have now four forces acting. Remember, whenever you resolve a vector into component, then the vector itself is gone because you have resolved it. So this W does not exist. In place of this W, now you have its component, W cos theta and W sin theta. And according to diagram, at the given condition, the box is about to slide. So clearly you can see, because the box is at rest. So this R and W cos theta are in opposite direction. So you can say that W cos theta is being balanced by R. So W cos theta is equal to R. Clearly, W sin theta is acting downward, frictional force is acting upward. And because again, the box is about to slide, box is at rest at that moment. So W sin theta is equal to friction. This is our most important condition for inclined plane. And that's what we can use. So now you can say that since W cos theta is equal to R and W sin theta is equal to F, which is a friction force, and we need to find theta. Remember, this is another key idea. Whenever you are given trigonometric equation in terms of sine and cos, so you have one equation involving cos, another equation involving sine, so cos and sine, and you need to find angle. Then the idea is you will have to divide these two equations. And why do we need to divide? Because we know that if we have sine theta divided by cos theta, this gives us tangent theta. So looking at this formula or this condition for trigonometric ratios, we divide this equation. So the second equation involving sine theta is divided by the first equation, W cos theta. So left hand divided by the left hand, right hand divided by the right hand. So W sine theta, left hand of the second equation divided by left hand of the first equation, W cos theta, is equal to right hand divided by right hand. So F divided by R. Now W get cancelled. Sin theta upon cos theta is equal to tangent theta, and F is given as 0.32. So you just substitute the value 0.32 times of R divided by R gets cancelled. Now tangent theta is equal to 0.32. So theta is equal to tangent inverse 0.32. Take the tangent inverse. Theta is equal to 17.74 and theta is equal to 18 degree. This is the angle that you needed to find. Okay, Thank you very much. I hope you understand this question, and I will try to complete this paper in some other day. There is some problem with my laptop, that's why I could not upload more video. I'm sorry about that, but I will try to help you out as much as I can. Thank you very much. Have a nice time, and may God bless you for your exam. Thank you.